Hi, welcome back to 1.5 Solving Quadratic Equations. In this video, we're going to look at example 4, where we use the discriminant. This is b squared minus 4ac, that part of the quadratic formula. We're going to use that just to determine the number of solutions in the quadratic. So it says here for each quadratic equation, so these three here, use the discriminant to determine the number of solutions. So they don't want us to find the solutions, they just want us to find the number of solutions. Okay, here we go. Let's do the first one. So our discriminant is b squared minus 4ac. Let's calculate this. This is my a value, my b, and my c. So just plug them in respectively. So b is 3. So we have 3 squared minus 4. A is negative 2, and c is 8. 3 squared is 9. Negative 4 times negative 2 is positive 8. 8 times 8 is 64. 9 plus 64 is 73. So b squared minus 4ac is positive. Okay, if it's positive, then it means there's going to be two solutions when you do the quadratic formula. So therefore, there are two real solutions. Okay, they're not only real solutions, they're also distinct as well. So we're going to put in here distinct solutions as well, which means they're not the same solution. They're going to be different from each other, and there are two of them. Okay, let's look at the next one. We'll just switch colors here. So I'll write out my discriminant and calculate it. This is my a value, b, and c. So b is negative 5, a is 3, c is 11. Negative 5 squared is 25. 4 times 3 is 12. 12 times 11, 132. That'll be negative 132. Okay, 25 minus 132, negative 107. So our b squared minus 4ac this time is less than 0. Okay, that means we would have a negative under the root in the quadratic formula, which means there are no solutions. There are no real solutions. Okay, you might be wondering why I'm using the word real here. So we are working with the real number system when we're looking for these solutions. So there are no two real numbers that multiply together to give a negative value. So that's why there's no real solutions. But in other number systems, such as complex numbers, those values actually do exist. So, however, we're not using those in this course. So, but we still need to specify the real solutions, showing that we're using the real number system. Okay, all right, and the last one, let's just switch colors to green. Right here, b squared minus 4ac. Let's do our substitution. That's a, that's b, that's c. So b is negative 3. A is a quarter, and c is 9. Okay, let's just zoom in over here a bit. Clean that up a bit here. Okay, so negative 3 squared is 9. And then negative 4 times 1 over 4. What we're actually doing is we're dividing the 4 by a 4. So this is just negative 1. So negative 1 times 9 gives us negative 9. And we end up with 0. Okay. So if our discriminant is 0, that means we have the square root of 0, which is nothing. We only end up with one solution. Okay, so b squared minus 4ac is equal to 0. Therefore, only one solution. Okay. All right. This is also, sometimes this is called a repeated root. And I'll explain that a little bit more later on what that means. Okay, let's go down to the bottom here. There's a little bit of a table. So just to summarize, if the discriminant is greater than 0, then there are two real solutions. Just switch to blue here. Two real solutions. Okay, and sometimes it's also worded as two distinct real solutions. Okay, the part distinct just meaning they're unique to each other. And here's an example. We could have a parabola open up, and there's our two solutions. I'll highlight them in red. The two x-intercepts there. Okay. All right. Now, if this would be the red case. So when the b squared minus 4ac, the discriminant, when it's less than 0. Okay, we're looking at that one now. That means there are no real solutions. Okay, and graphically what this means is that the parabola does not intersect the x-axis. Okay, there are no intercepts. And lastly, if it works out that the discriminant equals 0, then there's only one solution. So only one solution. Okay, and we actually say there are um, two equal real roots. Two equal real roots. Okay, that's also known as like a repeated root. So the reason why it's two equal real roots is because the parabola must be have the vertex right on the x-intercept. So the solutions are actually repeated. All right. Yeah, so that is for that. So you can either have one solution, okay, one solution for this case, no solutions for this case, and two solutions for this case.